everyone. Hi, hi, hi. Thank you so much. Thank you so much for taking out time on this wonderful day and joining us for our Grab Tech Talks. Today, we have Sylvain and Biju who are talking about CI/CD strategy at Grab. Just a couple of ground rules. This is a Zoom webinar, so slightly different from the traditional setup of a Zoom meeting. All the participants are, just a second, all the participants are on chat only. So feel free to type in and address folks on chat. Just make sure it's all respectful and in the right spirit. If you want to ask any questions, please use the Q&A button at the bottom of your Zoom panel to ask questions, and we'll be taking all the questions during the Q&A section later. Alex, can we have the slides, please? Okay, next slide, please. Okay, I'll just run over the agenda with you guys. Today, we have a little bit of introduction about what the team does by Sylvain. Then we move on to the build process, talking about the integration to staging and production deployments as well. Later, we also have our folks from our people operations team talking about the career opportunities at Grab. And we end with a nice Q&A session with all you guys. So feel free to tap on that Q&A button at the bottom and ask any questions, and we'll take them at the end. I won't take much time. Over to you, Sylvain.
Hey, good afternoon, everybody. If you're in the Asian time zone, or good day, wherever you are in the world. So today, Biju, my colleague, and myself, we're going to talk about CI/CD at Grab, as Isha introduced. And I want to define a little bit before we start the talk, what is CI/CD at Grab, and give you guys a little bit of an introduction also on what Biju and I are doing. So I'm a principal engineer in the Apex organization, which is a platform organization at Grab. We build and maintain and improve all of the tools that are used by all of the engineers at Grab. And traditionally, that was an organization that focused on how Grab started, which was mainly in the mobility domain. If you guys on the Zoom are still remembering the early day of Grab, it's just a taxi booking application. It has diversified a lot since. And what we're going to talk about today is how we supported this early transition from that transportation business to all of the business that are that are shown on this slide here. We're not going to talk about additional teams today, and so that defines what we refer to as Grab. And for the next slide, I'm going to talk a little bit about what we refer when we talk about CI/CD. So if you are technical and if you are a developer, you definitely are aware of what is CI/CD. You're probably using it every single day. If you are not a software engineer, that might be a new term to you. So CI/CD, continuous integration and continuous deployments, are two pieces of a whole that is generally referred to as continuous delivery. And continuous delivery, it's the ability for your organization to get changes of any type, features, configuration, bug fixes, experiments into production, into the hands of your users safely, generally, quickly if you can, but also in a very sustainable way. You want this to happen every day, all the time, continuously. And at Grab, like any other company of its scale, we have naturally invested a lot of effort into our mature continuous delivery processes that we're going to show you today. And we're going to give you a little bit of an overview of some of the roadblocks that we faced, how we went over it, and some of the tools that we used to do so. So back in 2017, when at the time Grab was mostly just a transport serving application, most of our backend services were written in monolith using Ruby, which is a dynamically compiled language. A small band of developers at Grab decided that we should break away from that model and move into microservices as Grab was going through a phase of growth. They decided to start a monorepository using the Go language, and initiated and kickstarted rather a spur of creation of microservices. So what you see here on your screen is a graph over time of all of the microservices that have been created from that repository only. There is, to this day, I think around 600 of them. But it, as you can see, increased really linearly over time and really quickly, right? So we've starting from that block of monolith into that journey of microservices, and the problem we've encountered is really the whole point of that talk, and how CI/CD and continuous delivery helped us, right? Where we are today is that we have 600 microservices, 140 commits per day, thousands of active users. We're doing almost 300 deployment on our staging environment, 6 million unit tests are being run every day, and 60 production deployment per day are happening. So you open your app, just for a couple of minutes, there is a high chance that something has changed while you had your app opened on the backend. That's quite incredible. So how did we make this work? We use, as I mentioned, a constellation of services. A lot of it has been built in-house, strong of the learning and knowledge that we've accumulated. And we're going to share some of that experience today with you guys. So I'm going to hand this over to my colleague, Biju, who's going to continue with and introduce himself first.
Thanks, Sylvain. Let me get to the right slide. And I should learn how to click the present button once the Zoom window goes away. There it is. All right. Hey guys, my name is Biju. I work as an engineering manager at Grab, looking after all of test infrastructure, test frameworks. What I'll start off with is the build process. So the build process is the first step in the CI/CD pipe. A traditional build process would typically look like something like this, where we take a bunch of code, run it through a whole set of processes, the linter checks, put it through a bunch of unit tests, and eventually the goal of the build process is to generate what we call the build artifact, which is effectively an executable binary, a binary that can be run as a service. That binary is then deployed out to multiple environments. So we could have the staging environment like we do at Grab before we push it out to production. There are tons of tools to do the standardized build process. The first of, however, we have a full build automation team sitting in Grab trying to take care of certain things that are specific to us. The first big challenge that we had to solve was build times. Now, for any of you developers who's not, who can't relate to that little XKCD comic on the right, you're probably not working in the programming industry, but the build times problem is significant at Grab. Why? Because we've got about 600 services, like Sylvain said, sitting in the monorepository. If you had to actually take that entire repository and build it and run all the tests on it, it would take up about 10 hours. And if you had to do that once every time there was a change put in, we have about 150 changes going in every day. That would, that's something that you don't even want to get into. How did we solve for the build times problem? So we've got this system called CIV2, which enables us to be smarter with the way we go about our builds. CIV2 basically draws out a dependency graph between every single package that lives in the monorepository and tries to map out which packages depend on the other. That image that you see there is not gibberish. Every single line there or every single character is actually the package name in black and pink on the edges of that circle. And the blue lines in between are actually the mappings of which packages depend on each other. So there's a blue line mapping one package to another. That's the scale we're talking about. Now that we have a dependency graph, we can now be smarter about what we actually want to build. So if we only built the packages that really changed in that commit, or the change that a developer pushed in, we can significantly reduce build times. Here's a classic example, right? So we have over 25,000 packages sitting in the monorepo. If you had to go and build all of that, like I said, it could go up to 10 hours. I pulled out a classic example of a service that we will talk about later. And in that service, you can see there's only 600 packages that it actually depends on. So we can be smart with how we build only these 600 packages. Secondly, there is always going to be the problem of flaky tests whenever you run tests. So we run a bunch of unit tests. Sylvain touched upon running 6 million unit tests a day. That is what we run just on the mono repository. When a test is flaky, meaning that it would sometimes pass and sometimes fail, you run the risk of a flaky test coming in the way of your pipeline and having for you to redo that entire pipeline, or have to wait again to run the pipeline all over again just because someone's put in a test that fails once in a while. How do we solve it? We've created a service called URS, a service that is effectively a centralized test reporting service. So any test that runs anywhere across the company at Grab, be it a unit test, a component test, integration test, security tests, end-to-end tests, etc., all just push their test result at the end of the test run into what we call the URS service. The URS service is pretty simple. It takes that, stores it into a persistent storage, and from which we can hook into our dashboard and have pretty looking charts and graphs that gives us good analytics. A chart might look like this. This is actually a snapshot from one of our services. I've wiped out the service name on top out there, but you can see that they ran 88,550 tests in, I think this was a 24-hour window, and you can see the trend of how they ran those tests. More importantly, though, I can go back into every single test case and see whether it passed or failed historically. In this case, you can see the test ran 31 times and happened to fail once at about 3:20 p.m.-ish that afternoon, which makes the system realize that this is actually a flaky test. Why this is super important is it allows us to then either stop or let the pipeline proceed based on historical data, not just when a test fails at that point. All right, the last big problem that we need to solve as part of the build process is we've got an overly complex environment. If you take the example of the core service that handles all of our bookings, be it transport bookings or food bookings at Grab, that service needs 80 other services for it to run all its core functionality. So if I had to test that service, I had to bring up another 80 services, each of which would have their own dependencies. The dependency graph is extremely complex, and being able to spin that up every time is incredibly time consuming. In fact, way too complex that it's not practically possible at this point. What we're working on, and this is still work in progress, something which has shown a lot of promise, is a tool that we call Odin, coming from the mythological figure of God that created Loki. Odin gets packaged as a little binary that a developer can download, and basically just say Odin start server, specify his service name. And what we would do in the background is we'd statically analyze the code, identify all the HTTP and gRPC dependencies that service has. For each of the services that it depends on, we will generate mock services, populate them with generated mock data, and then modify the service that we want to test to connect to this mock service, to this mocked environment. That gives us a contained environment where we can test any new change ourselves. Yep. With all of those tools, what we've come down to is that 10 hours of build time for the entire repository has now come down to 8 to 9 minutes on the median time, the P50 build time, because we only build relevant packages and we use some of the other mechanisms I spoke about. The build automation team at Grab has done a fantastic job to drive this journey, and it's something that they're very proud of. All right, Sylvain, back to you to talk about integrating to staging.
Thank you, Biju. Oh, just stop share. Thank you for that. Let me share my screen. All right. So we're going to talk about staging integration, right? You're out of the trenches with your build. You've tested it. You know it's ready to have a good binary. You want to try integration tests before you hit production to make sure that it gels well with whatever is running. So we have a complicated workflow to test something in staging. Once you bring it up there, you have to verify that your deployment is going to work according to our usual practices, which involves canarying an instance before the rest of the instance are being deployed. And you want to make sure that both versions run simultaneously. You want to do your smoke test, configuration, security test, functional tests. And then you want to finally generate your release notes, verify some sanity checks before you send it to production. So that workflow used to be done manually by all of the engineers at Grab. And one of the first things naturally that happens is that we had inconsistent quality practices, because all of this manual work takes a long time. And therefore you need to have a lot of diligence, and sometimes things get dicey when you're a bit stressed for quick release in production. So enter conveyor. Back in 2018, we decided it's time to switch to something that completely automates that process and leads us to a place where developers don't have to think so much about development anymore. So we built a tool called Conveyor on top of Spinnaker, who's an open source project that was created by Netflix originally. That tool is an orchestration process. It's the brain or the central nervous system, if you want, of all our deployments. It integrates with all of the other systems that Biju talked about and more that we will introduce in the next few slides. And the idea is that it takes the burden of the engineers and apply all of the best practices into our pipeline, which we call paved road pipelines, because they encapsulate all of these historical knowledge about what we need to do at Grab. So the main idea was to go with hands-off deployment. What are hands-off deployments? The principle is simple. You shift left as much as possible, meaning you try to do most of the thinking process and resolution of decisions ahead of the merge during your code reviews. Try to express as much into code as possible, do all of the human decisions that you need, run your automated test as part of your build process, as Biju already covered, but as soon as you merge, the automation takes over. And there you should not think about deployment anymore. Deployment should become a non-event. The only time where you need to intervene is when the machine can't take the decision for you. And so ideally, the machine pings you, you answer yes, no question, and then the deployment goes on or stops. So we're almost there. The way we did this is by standardizing, as I mentioned, all of the pipeline. And to get this standard pipeline spread across all of our projects and microservices, we built our own pipeline as code too. So that pipeline as called snippet that you see on your screen is the starting snippet to generate our standard pipeline. Just with these few lines of code, people that are part of the foobar service teams we'll be able to generate all our 7 standard pipelines that let them go through the entire development process with just a few clicks. We provide the packages, and naturally, we give some hooks for teams to extend and add some additional tests, add some additional metrics and monitors that we'll cover later. The second thing that we did is that at the end of the pipeline, we hooked into our policy engine. Our policy engine is called Sphinx. It's also a tool that we developed internally. And the purpose of Sphinx is to quality check some of the metrics that are either in the environment, either related to your deployment. So for example, once all of the tests have passed inside your pipeline, we want to make sure that certain metadata are present inside our dictionaries to make sure that your service is kind of green lights to go to production. We know what service this is before it goes into production. We want to make sure that it's going to run on the right version of images. We want to make sure that you're meeting some quality metrics like API coverage, flakiness, security test coverage. We only do this at the end of the pipeline so that developers are able to experiment on staging as much as they want, but only those builds that pass these criteria will be the ones that are able to be promoted into production. And that's the role of the policy engine. So for the rest, I'm going to hand it over back to Biju.
Thank you, Sylvain. Let me share my screen again. All right. So the other problem that we have when we deploy stuff to staging and we want to run integration tests is the problem that because we've gone into the microservices mode, there can be hundreds of microservices. So, we go back to that 600 number, but that means that if you think about the passenger application that the Grab app has, which commonly you and I would use, or the driver application, each of those applications connect to hundreds of services at the back end. What that means is if I want to do a full workflow test, a full test of a user workflow, I would need to simulate some parts of the backend, which I, as an engineer, do not control. So if I'm passenger app team, I would want to simulate some parts of the driver app. So to solve that problem, we have introduced a service called Marionette. Marionette is, the guy who controls all the puppets on stage, and similarly on the Marionette, the service is the one that takes all the requests, simplifies an interface, and then simulates behavior back to any test script. Why is this super important? Is because if I go to the next slide, there it is. The SDK provides a really, really simple interface for an engineer to run basic behavior. Example, he can say marionette.login passenger, pass in a passenger ID. What services need to be contacted is not something that the engineer needs to worry about. It all goes behind the scenes. Login passenger, logging in a driver, changing the way the driver behaves, whether to automatically accept a booking or not, creating bookings and making sure that those bookings actually get allocated to the drivers that you wanted to for your test. All of that is encapsulated by this service called Marionette. It provides the ability for engineers to write integration tests without having to worry about areas of the backend that they don't need to worry about, and therefore making testing on the staging environment much easier. Just going back to that previous slide, there's a blog that we've put out about this, about Marionette. So I'd encourage all of you to go through that if you're interested in this space. Lastly, when you've got a shared environment where everyone's testing different behaviors, there's hundreds of services running, thousands of instances running there, you're bound to have failures. You're bound to have lots of failures because someone's changing something at any point. And debugging those failures can be really, really, really painful. So again, as a platform team, one of the objectives is to try and simplify the lives of engineers. And how do we go about doing that? Is, if you remember the URS service, we've got the ability to track every time a test failed. What we've also got is the ability to track why a test failed. And why that is important is when a developer looks at this particular chart here, he'll be able to see, and I've taken a test which has failed multiple amounts of time. This is actually something that is a really good example. So if you look at this test has failed 8 times in that time window. And why did it fail all 8 times? It failed because the booking, and presumably the transport booking that they were trying to simulate in this case or test in this case, did not get allocated to the driver that they wanted it to. And all 8 times, it was the exact same reason, failing on the exact same line of code. So this now goes back to give the developer the information that if he just fixes it in one place, everything becomes more stable thereafter. Even more interestingly, if I clicked on that failure reason, what it would show me is why, or rather what other tests would have failed because of the exact same reason. So if I filtered by the same reason of bookings not being allocated, I can see that it just didn't affect that one test which we just saw. It affected 4 different services and a whole bunch of tests, 3 different services in this image, and a whole bunch of different tests were all affected by the exact same reason. And therefore helping us to debug and troubleshoot common problems that occur across this shared staging environment. So again, these are problems that we've solved specifically at Grab, and these are problems that have, or rather these solutions have really helped make lives much easier. What has all this resulted in? So 25 minutes in the past to deploy something to staging. With the conveyor pipeline, it now goes down to 2 minutes, and that's a little bit overstated, I think. 15 steps down to 3 steps. It's just a very basic click-through process that gets your binary into staging. And we had about 12% of all our integration tests with a failure rate of 50% or more not very long ago. With all the tools that we built around it, we now have gone to less than 1%. All right, so once a binary has gone through the staging process, we now need to take it to production for users. Sylvain, back to you.
Thank you, Biju. All right, so as Biju mentioned, we're taking now that binary, which we validated into production. And production deployment is pretty similar in context to staging deployment, right? We want to ensure that we are redoing most of the same processes and we are redeploying exactly the same things, right? And one of the first things that we actually run into, one of the first problems that we hit is really what did we test? And what I mean by this, to understand that problem, you have to try to understand what's happening in the production environment and particularly what controls the behavior of the service. So you imagine you have the sea of services working on the cloud, 600 of them. All of them are not just controlled by the version of the application, but also the configuration information that they are loading at start or that they're receiving dynamically while they are running. Because we have 2 different types of system at Grab to do this. And one of the things that each of these things can alter the behavior of the services. And so what you have tested in staging, if it's not exactly the same as the same configuration set that what you are putting into production, you might not have tested the right thing, and therefore it might not be a good sign that your service is working. So how do you make sure that it is tested? Well, we made deployment reproducible by tracking every single kind of changes that are happening on our services. So we track changes for configurations, whether it is static or dynamic, for instances, AMI versions for services on AWS. And those who know that, we track the application version naturally, and we make sure that only the combinations that we have seen before, either in production or in staging, can be deployed in production. So for example, one of the failure cases that we used to run into is that without our hermetic principle, when you had deployed a new version to your environment, if you updated the configuration dynamically, but then decided to revert the version because a problem occurred, you might end up being in a situation where your past version was not compatible with the new configuration. And that caused some failure. So with our new hermetic system and principle, our pipelines are now able to recover the version, the complete set of information that was tied to that past application version. And this is what we redeploy completely. And that way we are sure never to run into that problem. And we are also certain that what we put into production is what was actually tested in staging. So we also had pretty high resolution time. When we deploy 60 changes per day, day in, day out, it requires quite a number of people to be behind the scene to be able to handle whenever an incident occurs and jump on that call, where everybody screaming for help to get these things sorted out and resolved, because we don't want to impact our users, of course. One of the ways we made our deployment safer is by automating that process completely. So deploying was like putting your canary into production. So I'll come back for those of you who are less technical to what a canary is exactly in the later slides. Once your canary is running, you have to monitor it. And monitoring a canary basically means watching stats and logs for the entire period of the monitoring. And that can be pretty tiring for the engineers before you put it into full deployment. So what we did naturally was to automate that process and we take the human out of the equation by giving the developers the possibility to hook alerts from Datadog into Conveyor. We gave them the opportunity to step away from the monitoring process. And now, during any deployment, when an alert occurs, Conveyor will immediately revert the canary and abort the deployment. This is a lot faster than asking people to just join a call and perform manual operation. It generally reverts within a minute. There's less fatigue for the developer, everybody's happier, and the system is just more stable. What also went wrong is that with this amount of services that you have to deploy, our rollouts were sometimes too aggressive. We would roll out at any time of the day, any time of the night, and sometimes too quickly. So we started to have pretty early on deployment windows. And what you see on screen is the daily seasonality of our data. Right? You can see during Asian noontime peak hours, people are making orders. These are also the time where we have the most people in the office in Asia. There is also a development center in Seattle, and there is also a lot of eyes on the system during that time. So we decided to clamp deployment windows only when we knew people were behind their desk or behind their computer now that we're mostly working remotely. That allowed us to ensure that if anything goes wrong, we don't have to wake up anybody. And therefore, deployment always happened a bit more securely. Second thing that we did is that we allowed on-call engineers the ability to control and pause the entire organization and stop the entire organization from deploying just with a single command on the Slack bot. If anything really big, if a major incident hits us, we can stop all of the deployment across the entire organization to ensure that a problem that is already maybe difficult to debug is not made worse by all the changes going into the system. Finally, some of the other things that we do that are more granular is that we created new developments, new rollout strategies for our deployments. So we used to allow only canary as a rollout strategy. So what a canary is if you have a cluster of, let's say, 5 instances, as shown on the graph, They are all in a particular version that is composed of your configuration and your app version. If you want to test your new version, you take one of these instances and you turn it into that new version. So a certain percentage of your traffic is now going into that new version, and you can verify that that new version is working properly in production before applying it across your entire cluster. And that's basically the canary process. Now, the one downside, it's a pretty good process, but one downside with that process is that when we go from the canary to the full deployment, all of a sudden you jump from just a small percentage of your traffic to the whole of your traffic in the new version. And what might happen is that some alerts don't get triggered on the small little canary because it's not enough of the traffic to hit these alerts. So we modified our rollout strategy by allowing teams to have different rollout steps and giving them moving these rollout steps equally across that monitoring windows, while at the same time having this system continue to monitor the alerts and make sure that it gets rolled back in case anything happens. And that made our rollout much smoother for teams with large clusters. So all these new practices brought together the system failures down by more than 50%. So we used to start at a failure rate of 1.6 per deployment. And in spite of the number of deployment increasing over time in 2019 to 2020, our failure rate actually went down dramatically once we started to roll out all of these improvements into our system. And today it remains quite low. So I hope you've enjoyed all of these insights that we're giving you guys, and that you have plenty of questions which we can't wait to tackle. But first, I'm going to hand over the panel to Claire, who's our PUPS representative, who's joining us today.
Hi, everyone. Thank you, Sylvain. And yes, I'm actually part of the talent acquisition team. This is Claire, and actually I support tech hiring in Grab in general. Alex, could I go to the next slide, please? Thank you. So if you see on the left, these are the roles broadly that we are hiring in Grab Singapore specifically. You can find these roles also in our careers website. Right. Moving on to the next slide. The typical interview process would take about 3 to 5 rounds, depending on the seniority of the roles. And in the areas of assessment, we would look into things like technical skills, leadership skill sets, people management, if let's say this is going to be a people manager role. And I think very importantly, is also a good culture fit to Grab's culture. Right. So please do look out for the roles that we are currently hiring from our careers webpage. So each time you submit your application, if your profile is being shortlisted, the TAPPs or the talent acquisition business partner will reach out to you on the next steps. We look forward to receiving your application. Thank you. Let me just pass it back to Sylvain and also Biju to help to address the Q&A. Thank you, guys.
Thank you so much, Claire, and thanks Sylvain and Biju for taking us through an amazing talk. There are a lot of questions. We have 18 questions in the pipeline, so let's try and cover all of those as much as possible. I'll bring up the questions and then we can answer. So the first one, or rather a few related questions, are around flaky tests. The first one says, how do you deal with flaky tests during the unit tests? Then there's also one question that says, once identified, how do you actually address flaky tests? And there was one more question, how do you identify flaky tests in integration environments? So all of these are around flaky tests. So I believe, Biju, can you shed more light?
Yeah, I'll take that one. Sylvain, there's a lot of questions around tests. I'll distribute it out with you.
Yeah, no worries.
They don't get bored hearing my own voice. So I'll take the flaky test one. So let's go with the one with how do we deal with flaky tests during the unit test stage. So there's multiple strategies that you can use. Obviously, one is to just rerun the test when it fails. That's obviously not helping with the fact that the test remains flaky and continues to pose a threat in the future. Like I said, the way we're trying to tackle that is by storing historical data and knowing whether the test was always flaky And if it was always known to be flaky, then there's no point stopping someone from pushing a new build because there's just too many tests to go and clean up. But what you really want to stop is a new test from entering. That goes without saying for both unit and integration. The question about how do you address flaky tests? That's a really good question, because we're talking about thousands of engineers at Grab sitting across different regions. To be able to turn on a policy or to be able to just mandate that all tests are fixed overnight is not practical. I think where we as a platform team need to be sensible is to try and figure out how best are we protecting ourselves from the risk that is posed by those flaky tests versus how much time is it going to take. One of the strategies that we've gone ahead with is to put in gate checks. Sylvain touched upon the policy checker stage that we have right at the end of the deployment pipeline. And we use that to block deployments if a certain condition is met. And those depend on whether, for example, if the test fails more than a certain percentage of times, or if the test has 0% coverage or X number of, it's useless. What if someone puts in a test which just has assert true? It makes no sense. So, being able to start there and then tightening up the screws is the strategy that we've gone with. Again, it's a long journey, and that's something that we are on the path to. The third one, Isha, and I'm trying to find that.
The third one was from Abhyankar that talks about how do you identify flaky tests in integration environment?
Oh, yeah, that's a good point. So similarly, like I said, irrespective of where the test runs and what the test, irrespective of the type of test, unit component integration end-to-end, or non-functional tests in security tests, or in some cases performance tests, every time a test runs, we publish the test result into a centralized service. That service is still in-house. We've not published too much about it. It's relatively new. It's about 12 months old. But the ability, the fact that we have all the data in one place gives us the ability to identify whether a test is flaky or not, because it's just a simple database and you filter by test case. So again, it goes back to the point of once we identify what do we do, that's what I just addressed.
Cool. Let's move on to the next set of questions. Alamsia has asked, can you share a bit about your Git branching strategy for Grab CI/CD?
Do you want me to take that one, Biju?
Go for it. Yeah.
Yeah. So we're using a trunk-based development strategy on the monorepository. Right? That's one way we can ensure that everybody uses the most up-to-date dependencies in their build with every single build of an artifact. That happens, naturally when you use a monorepository.
Okay. Thank you, Sylvain. There's another one. During the migration from monolithic to microservices, what are the best practices and challenges encountered to increase test coverage and automation, as well as when grouping packages to minimize build time?
Yeah, I can talk to it, but to be honest, from the time I've been at Grab, which is about 1.5 years, we've been pure microservices. But some of the pieces that you, again, like I said, is to make sure you have tooling around these. So there's academically, microservices is the new in thing. Everyone wants to jump into it. I think it's very important to realize that when you get into a microservice architecture, there are certain foundation stones that need to be in place for it to be effective. Or else you're going to see more problems sometimes than what you would have had if you just had a single monolithic application. So building the tooling and some of the pieces that we touched upon in today's talk about how do you make sure you're building the right packages, how do you make sure you running the right tests, selection of tests is super important. And making sure you know how you can trace from one to the other is very important. It's a whole topic in itself. I don't want to. I think getting into any of those will be will be a nice long discussion. But in general, microservices needs your automation tooling or your DevOps tooling to be up to speed, and I think that's an area to focus.
I'm going to add something to that as well. When you're going to start to go into a completely new direction, one of the things that we found was extremely effective at Grab was to automate our scaffolding. So you imagine everybody was working on that monolith, and all of a sudden we want people to be able to create microservices. We just simply automated the creation of the microservice just through a few clicks. And what we did is that we created a pipeline, a workflow that would templatize your project inside the monorepository, generate all of the initial tests. So it would just be a hello world, generate all the initial tests, generate all the access that you needed to deploy that service, and even all the way to staging. And in fact, we would build that service and deploy that service. And that's done within 1 hour. It's a completely automated pipeline, and that sets an harmonized skeleton for you to start building added value and business value into your service, and without you having to determine what is it that I need to initialize and what are the best practices. So basically automate your culture if you can.
Cool, thank you. Just keeping track of time, we have about 10 more minutes to go. So let's try and cover as many questions as we can. We still have 24 more questions, by the way. So we might take these questions as we go along, just so we have a recording at some point of time that we can share with the folks. Let's start. So the next one is about Odin. I think there are a couple of questions. I'll club them up as well. How is Odin, this is from Vijendra, how is Odin different from SonarQube in stats code analysis? And there is one more question. It seems to me that Odin and Marionette are simulation pipelines that ease developer to test their new scripts or services. May I know what is the major difference between the both, or are they just pipelines, different pipelines on different development stages?
Yeah, take that. So Odin, how is it different from SonarQube? I think you mean static code analysis, not stats code analysis there, but how is it different from SonarQube? SonarQube has a bunch of pre-checks to, templates to tell you what, what your test coverage is. It tries to pull out code styles and tries to give you suggestions on how to improve your code. What we're trying to achieve with Odin from the static code analysis is to identify dependencies via HTTP gRPC. Now that can be pretty challenging because, for example, someone can just go and spin up their own HTTP client and connect to a particular HTTP URL. So it's not standard because of the scaffolding that Sylvain spoke about earlier. We have a mechanism to figure that out, and that's where we use Odin. How is Odin different from Marionette? Odin has mock data. So it is a mock service. A mock service meaning that it is an empty service. We just spin up an empty Golang service populated with mock data. It just gets a request, matches it up, and sends out a request. Marionette, on the other hand, is like a real Marionette. It gets a request and it actually simulates the behavior by calling the exact services in the staging environment. So those are real services. So that's practically the difference. Odin will be used in the CI part, in the build part of it. Marionette predominantly in the CD part when you're testing your staging deployments.
Cool. There are a couple of other questions on Marionette that I'll bring forward now. So one from Sumit that says, does Marionette set up infrastructure at runtime and bring necessary service into the setup? And does it run on AWS infra?
No. Short answer, Marionette does not set up any infrastructure. Marionette just redirects requests to the right service. You just send a request and it redirects to the correct service.
Is it set up on AWS? Does it run on AWS?
A lot of Grab infrastructure does run on AWS. We do use other cloud providers as well. Like I said, Marionette at its level just redirects requests to wherever those services are run, and those can be across different cloud infrastructures.
Thank you. I don't know if this is covered. Another one from Vijendra. Could you tell a little bit more about Marionette? Like, how is it reducing dependency with services and integration tests?
Like I said, the idea is if I'm testing one part of the app, Example, I want to test a booking, and to test a booking, I need to have a driver that accepts my booking. If I want to test, let's say, the booking fare, for example. So I need the driver to accept my booking. I need to know which service to call to accept my booking. And as a developer who's not related to the driver tech family, it's very difficult to find that out. So Marionette, you can just go to Marionette and say, hey, Marionette.accept booking, and it will do it for you. So the idea of Marionette is it simulates a large part of what the Grab app can do so that anyone can use it fairly easily.
Okay, thank you. Another one from Alamsia. Do you have certain failure rate to auto reject the deployments? For example, if the failure rate is greater than 5%, then auto reject.
Sylvain, I'll let you take.
Yeah, so we don't reject the deployment per se. What we do is that we prevent teams to promote into production. So promotion is disabled. That's the purpose of our policy checks at the end of this pipeline. So we let teams experiment on staging, but only those versions that are compliant with the policies will be able to be promoted into production.
Cool, thank you. Sorry, I lost track of all the questions on Zoom, so the main question got lost. Okay, the next one is from Vivek. In build stage, what exactly do you do in lint stage? Do you pass and lint Docker files or just scan app code? Any specific tool you would suggest?
Sorry, Sylvain, go ahead.
Yeah.
Just one question. Yeah.
Yeah, I'm just scanning the question. If you have an answer ready-made, Biju, go ahead.
The lint stage is just basically to make sure that we adhering to certain standards across the code base, across the monorepo, and again, there is 1,000 active contributors, and you're going to have different coding styles. You're going to have different practices. The lint stage is effectively just to standardize across the repo.
So just to complement a bit, now I found what I wanted to say. And we based our processes of review and LinkedIn upon Fabricator. So there's a hook inside Arcanist, which is the CLI for Fabricator that runs lint stage, and you can configure some patterns. So we have different type of linter based on the glob of the file. So if you're having a Docker file, we have a linter for Docker. If you're having a Go file, we have a linter for Go. And generally, we use the standard linters that everybody is using. Right? GoVet, GoLint for Go. For Docker file, that would be another linter. For JS, that would be JLint, JSLint, and others.
And also, just to add on, just very quickly, is we have our own linters for files that are internal. So Sylvain spoke about pipeline as code, where you configure your pipeline using our own internal, language syntax, and therefore we have our own linter checks around that.
Okay, thank you. There's one from Blessy that talks about, is there any post-release testing?
Isha, I think you might have missed, I think there's 2 questions on top.
Oh, I'm so sorry. I think I didn't scroll up. Yeah. How extensive are feature toggles used at Grab?
I'll take this one quickly. So we have 2 systems for feature toggle, mainly one which is more backend centric, and one which goes across our entire app, and they manage really tons of variables. Like, I can't give you the numbers, but it's a very extensive amount of variables. So the main difference between these 2 systems is that one of them tends to produce configuration parameters, while the other really just modified toggles. They are both covered into one of our Grab blog posts. I recommend that you do a quick search on Google around building Grab experimentation platform. And that will give you a lot of information on the feature flag management system that we use at Grab.
Thank you. Just in view of time, we have 3 more minutes. So officially, I would just like to thank everyone. We can continue to take on the questions, and you can stay on call if you have time. There's a quick poll that just
actually, Isha, before people drop off, I just wanted to say thank you very much to everyone who dialed in today. One of the other things that we are very keen to hear from is to hear from you about what are some of the topics that you would like to see in the public domain, either in the form of blogs or open source, open sourcing some of our tools that you might find useful. So please do reach out and let us know from the feedback forms. And we've got a lot of open roles in both Sylvain's team and my team. So if you are interested in the space, please do reach out. We'd be very happy to have a chat.
Thank you for the plugin. I was just going to say, as you dial off, you might be redirected to a web page that will help you just sort of fill up a quick feedback form for us. Let us know things that Biju talked about around blogs and external posts and even talks. And also let us know if, how useful did you find this talk? And that's about it, but we can continue. We are not ending here. I would like to answer majority of the questions. I would say there are still a lot. We're at 19 questions, but let's start. There is a question from Sumant that talks about, can we see a demo, which might not be possible, but the questions around any reusable plug and play kind of pipelines, which can be technology agnostic, like pipeline as a service. Would we want to just talk about this?
Yeah, so briefly, we are using Spinnaker for all of the machinery behind Conveyor. Conveyor is really a convenience layer that was built for users of Graph so that they find very quickly what they needed to do. But internally, we use and reuse a lot of the tools and blocks of stages of pipelines that are already provided by Spinnaker. And we've also contributed, I think we are at our 18th code merge or more back into Spinnaker. So we tend to contribute quite a fair bit of fixes or improvement into Spinnaker. So if you use Spinnaker, this would be my recommendation. You're going to get already these building blocks that you are looking for. And they're mostly technology agnostic, meaning like cloud agnostic.
Thank you, Sylvain. There is one question that I had covered before, but we were distracted. Is there any post-release testing or health check phase in Grab CI/CD? This is from Blessy.
So I suspect the question is, do we run any tests in production? At this point, no, the answer is we do not. And it's something that we are working towards, but no, not at this point. Nothing automated, I should say. Yeah.
Next one's from Shilpa. Can you please give more details on how the manual intervention was removed during deployments?
Yeah, that's a great question. So basically, it was down to a minute details of going and talking to all of the developers and trying to figure out exactly what it is that they're doing on a daily basis. And whenever they have pain points, we try to automate those pain points. So we spent a lot of time discussing, listening to feedbacks coming from our colleagues that are sitting next to us, basically, to try to figure out how we build our tools so that they don't have to spend a lot of time toiling and spend more time building. So a lot of it is customized because a lot of it is related to some of the specific way we work at Grab. And that's why we don't, we don't necessarily share this outside because it's very Grab specific.
Thank you. The next one is, how does using Dockerized services compare to setting up mock services for testing purposes?
Yeah, I'll take that. So the problem that we needed to solve with mocking services is not to set up that one service, because setting up one service can be solved by Dockerizing it. The problem is, like I said, if you have service A and it has 80 dependencies, each of those dependencies have X number of dependencies. That is that is the problem. So the idea of mocking it is to cut the dependency chain, is to not have to traverse the entire dependency chain, which is the massive problem that we were trying to solve. So yeah, that's why we went down the route of mocking instead of just spinning up Dockerized services. Ideally, if the dependency graph was not as complex, you're right. Dockerizing each one and just spinning it up would have worked.
Cool. Next one's from Celine. Monitoring can create noise. Which critical metrics in Datadog automatically abort a production deployment, and how were they identified? Are they service or feature specific?
Yeah, it's a great question. And I want to say yes. So let me explain a little bit. When we started to look at monitoring, a team was dispatched to basically look at the problem of what are those metrics that we need to roll out across all of the services. And we created this concept of golden signals. I think there are 6 of them today. They're generally telltale sign, like surefire, like this is a crappy canary and you get a rollback. So restart loops, right? From the logs, it just keeps on rerunning. The number of 5xx's is really all of a sudden really high. The API traffic just goes down, like basically it's bottleneck. There are a few more, but they all resolve around the same concepts of either choke, failures, restart problems. So these are our signals. The other thing that we did as part of our configuration is we actually let team expand on the monitors that they select. So if teams have some specific monitors that to them are telltale sign of a wrong canary, they can configure it as part of the monitoring. And so the system will watch for that as well. So we let team basically configure what are the alarms that they think should trigger the rollback.
And again, because we've got the scaffolding in place, monitors are also pretty, or all metrics that get published out have a certain standard to it. And that foundation stone helps in that process.
Yeah, absolutely. The golden signals get generated for every new services every time. Yeah.
The next one's, thanks so much. Are developers responsible for testing, or is there a dedicated QA team to do the testing?
I'll take that. So there's a mix of software engineers, QA engineers, software engineers in test. And again, like most other large companies, we've got a mix of all three. A large portion of our community is software engineers. We do have a QA engineering community and STETs as well. So yes, each product team can choose how they want to structure that team. As a platform team, we build the tooling, and so we are not the QAs, but each product team would have either QAs or STETs to help them out, or sometimes some products just have engineers doing all the tests. So varies across the company.
Thanks, Biju. For Canary Deploy, how do you ensure the compatibilities between the app or web that consume the API services? For example, the existing web or app version might only work with the current version, but not the entirely compatible with the new deployed API.
Yeah, that's a great question. This is a huge problem, and I'm going to disappoint you by my answer. Actually, we offload that responsibility onto the service teams themselves. So we have a principle that if you are going to modify your API, first of all, you should version your API. And if you are going to modify it, you need to support your backward compatibility. So there's a principle, we've defined a set of ownership rules at Grab. We just, someone in the organization, a colleague of ours, just published a document about it. So it's now formalized and codified. Basically, you have to be cognizant of your dependencies. And if you are going, your immediate dependencies at least, not the transitive ones, but the immediate is super important. And if you are going to change something, it's your responsibility to inform people that depend on you that you're going to make these transitions. And sometimes deployments, because of that, needs to happen in lockstep. Like if you know a team is going to release a dependency that is related to your feature, and you want that feature to go into production, you have to make sure that they deploy first to get your dependency out before you release your own feature. So we kind of decided, like, let's not try to solve that problem because it's extremely complex. Like, let's push that back into the responsibility of teams which have to manage their product, like in this ecosystem that is Grab.
And again, you can just to add on, you can always make sure your changes are backwards compatible by either spinning off of, by versioning your APIs as well. So again, product team's responsibility, but can be done.
Cool. The next one's by Abraham. Is this container-based deployment or VM-based deployment?
That's a great question. We are still VM-based deployment mostly for the services, because it was started quite some time back, and we are moving to container-based deployment. A lot of teams have already addressed this. We didn't cover that in the talk. There is a fantastic amount of services that are running on Kubernetes now, but we chose to address that portion of the talk that was around VM-based deployments today.
The next one's from Abhyankar. Does Grab do chaos monkey tests like Netflix?
No, not yet. It is one of the things that the engineering community at Grab have voted up in their list of things that they're looking for. At this point, though, we have other pieces that we're looking to solve first, but it is on my agenda. It is on my radar.
Which database, next question, which database would you prefer to store the historical data for flaky tests?
While we were preparing the slides for this, Sylvain, another engineer within another very smart engineer within the company, and myself were sitting and talking about this yesterday. It is currently stored in a relational database. Does that scale? Maybe, maybe not. What is the ideal state is something that we are still figuring out. One of the engineers in my team has written a first version of this document, but yeah, it is something that we want to get right. When we first built it, we went RDMS just because we didn't know whether this would work or not. So we wanted to go, quick, get something working out there. Today we need to get this right. There's another question that someone asked as to whether we're using elk for it. I'm sure that would have brought a smile to Sylvain's face, because it's Sylvain's suggestion to go down that route. It is one of the possibilities that we are considering. And yeah, we will come to a conclusion pretty soon once that document gets circulated across the engineering community. At this point, RDMS, simple answer.
Okay. Any future plans to open source some of the internal tools that you guys shared in this tech talk? I don't think we can answer that, but we would still, would someone like to talk about the whole open source bit at Grab?
Yeah, I think we can still answer some of the stuff here. Like generally speaking, at the moment, there is no specific plan for specific tools, but we are trying, in fact, not to reinvent the wheel whenever we can, only when there is very Grab specific process. So a lot of time, we rather just contribute to existing open source processes and tools, because there are so many of them available for CI/CD. I think for specific tools, that stance might change in the future, but the open source process is something that needs to be considered and done well for it to be beneficial to the community. So that's something we might consider in the future, but as far as I'm aware, not now. Or do you know anything else, Biju? Do you want to add something?
No, but there is some chatter within my team as well to see what are some of the things that we can put out there. If anyone finds a particular piece of the tooling that we spoke about to be useful, do let us know. Do reach out. Do connect with us. We'd love to connect with people and understand what you'd like to see us put out there, and we will take it forward. But at this point, are we working on open sourcing something? At this point, no.
Next questions from Sumant. Do you also use feature activation? I believe some of this was already answered, and we would point folks to our engineering blog section where we have a blog on experimentation. So I'll take that. Let's move on to the next one. How is check policy rules different than code review rules?
So code review checks are things that there's few, right? So you can do linter checks at that point. You can run unit tests. you run things that are isolated. The policy rules that Sylvain spoke about kick in at the time of deployment to staging. That is, so you want to run, you want to check whether your API tests have met a certain quality. Like I said, if someone's put in API test to say assert true, not hitting any APIs, pretty useless. We'll pass all your metrics and go through, but you want to block it at that point, or you want to flag it up at some point. So rules that you want to make sure that you're maintaining certain quality standards, security as well, whether you are testing every possible case from a security point of view, which can only be done at the staging environment, cannot be done at CI. Sylvain, so if you have anything else to add.
Yeah, that was good.
Cool. This was actually all the questions now are answered after we started answering the questions. So these might be follow-up questions to what we've already answered. Regarding trunk-based, I think this is again, maybe this calls in, the question is regarding trunk-based development, is feature toggles used and how is it not abused in systems? Maybe this is a sign for me to bring a talk on experimentation at some point of time. To
Yeah, absolutely. I think that would be fantastic. Or bring also a talk about UCM, our configuration management.
Yeah.
So we have, just quickly on this, we do have feature toggles as well, as we mentioned earlier. So there are the features that I'm going to refer to, they are not part of our application monorepository, right? The monorepository contains a lot of the configuration and features that control the behavior of the system, but we also have a dynamic system on top of that. In fact, two dynamic systems, the experimentation platform and the configuration manager. And they can be used to change the behavior of the tool at runtime. So how is it not abused? We control this. It's a fantastic question, by the way. We control this in two different ways. From the dynamic configuration, which are more generic configuration for the service, we track every single change. So again, it comes back to our principle of hermeticity. Like every change, every toggle is treated like a deployment. For the experimentation platform, where the toggles are much more contained, there's different sets of controls that are being put on top of it. And notably, we ensure that there is not too many experiments going on at the same time. So there's a scheduler of experiments. And we try to ensure that there's no conflict in experiments through some rules that are being put in place. And you can read all of these into the experimentation platform blog, which I recommend.
I think I have my speakers for the next talk already. Do you, next question, do you have a specific team on each platform like iOS, CI/CD, and that maintain the environment and are suggesting improvements for CI/CD?
Yeah, so we, just going back, organizational structure, Sylvain covered this in one of the slides. We fall part of the Apex organization. I'm trying to get the full form of that, automation and platform excellence organization that basically has different teams focused on different parts of the CI/CD pipeline. So there's a build team, there's a test team, there's a deploy team, it's a common frameworks team, and some parts of this are separate for mobile and separate for backend. In addition, we do have specific teams for each of our applications. So we've got 3 major mobile applications out in the market. There's a passenger application, there's a driver application, and there's a merchant application. So the shared pieces, shared libraries that are used in those specific apps and shared build processes and whatnot. So there are specific teams to handle that.
Perfect. Let's move on to the next one and hope to end soon. There was a mention of API test coverage. Does this coverage refer to source code coverage, and how is API level test related to test coverage?
API level tests related to test coverage. So different types of tests, you want to calculate coverage differently. Unit tests, you want to cover it, you want to calculate whether you're hitting all your lines of code, whether you're covering all branches, etc. API tests, you want to make sure whether you're hitting all your APIs. I mean, depending on the purpose of the test, you want to calculate coverage accordingly. It's a vast topic. I am planning to put out some of this in a blog pretty soon. hopefully, to encourage more opinions coming through. At this point, API test coverage, we have 4 different ways of calculating it. I won't get into all the details here. Hopefully, I can put that into a blog, and we can take that discussion further. Again, connect offline if you're interested in the space, and we can talk about it.
Cool. Next one, we have 6 more questions. I would still, does everyone have time? I just wanted to ask Sylvain and Biju, are you guys?
Yeah, I do.
Okay, perfect.
Yeah, I'm fine.
Perfect. Thank you. I would want to continue with, by the way, there are also a lot of internal questions after this that I'll point you guys to that you will have to answer. Let's move on. On simultaneous tests, do you run this process on bunch artifact at the same time?
Simultaneous test. Sorry, I'm not quite sure what the context of this is.
Okay.
I think maybe the person is referring to the fact that the tests are run inside the environment, right? So they hit, they impact transitively the behavior of all the services running.
Possibly, yeah. So we do have a centralized test execution service which runs all our backend tests and mobile tests. Just make sure that the test process itself is containerized and isolated. But in the case of integration tests, you're hitting a shared environment. If that was the question, I'm sorry if I didn't answer it. Please do reach out again.
I think Surya is still on call. Surya, if you want to just type something in chat and let us know if there's anything else, we'll move on to the next question in the meanwhile. Would you prefer Kubeflow versus Seldon?
Sylvain, any thoughts?
Yeah, so look, GH, I'm going to be super transparent and frank here. I actually had to Google what Seldon is. And I think, Isha, yes. I do have some knowledge of what Kubeflow is because I've heard about it. But Isha, I think you have your second next talk, and it's probably about ML and machine learning topics in general.
That's what I picked up. To be honest, in all vulnerability, I had to Google Seldon as well. So I think ML is definitely something that we all need to bring in. Let's move on. Let me just dismiss this. Let's move on. Has Grab adopted? Oh, I think this is also ML. So let's move on.
Yeah, unfortunately, we do not have the expertise. Apologies, but we can point you to the right people if you want us to.
We are going to cover the questions relevant to the topic as well. Is there a rate limiter check for a particular user or server instance? Does CI/CD integration test take care of it?
Sorry, what was that? Is that a link?
Yeah, it's about rate limits. I can start with this, and then Biju, you can continue if you want. So we have rate limits. So our rate limits are extremely granular. They are applied at plenty of different levels. Between services, we have rate limits. We have microservices that are built just to be able to centralize counter of rate limits. So at every single step of the call flow or the call tree across the environment, there are rate limits that are being put in place. It's not completely standardized though, and interestingly, this is a topic that we discussed quite recently internally. So we're going to try to standardize rate limits on every single call.
To answer the second question, to answer the second part of that question, Sylvain's covered how rate limits work at Grab. Does CI/CD integration tests? Does CI/CD integration tests take care of it? No. The answer is, again, integration tests are what a team puts in general. From what I've seen, no.
So I think also maybe you can cover a little bit of the load testing.
So we do have a separate framework to do load testing outside of the integration test framework that can simulate a certain amount of load and run a certain function so that you can at a certain QPS. So in that framework, you can potentially hit your service and test your rate limits. But again, that's a very different topic that goes into non-functional testing, into performance testing.
The next one is, do you apply online schema migration to your microservice pipeline, like Persona PD online schema change?
Yeah, so we do for relational databases. It's a brand new feature that came in that was released, I think, second half of last year. It's still very much in development, but we indeed try to automate that as well. So it's an interesting topic in itself. Yeah, good topic for a talk too.
Thanks, Sylvain, for giving me so much work. Yes, I think there are a lot of other questions, but we'll take the next two and end. While designing the microservices, do you use Swagger?
Yeah. So we do have Swagger docs generated out of every. So the foundation layer, the scaffolding layer, does generate a Swagger doc for every service. We do use that for determining API coverages, to determine what APIs exist on that service. We do use that to publish that out onto our public interfaces as well.
Cool.
So any other case you want to talk about in terms of usage of Swagger? I know those are the two main ones.
Yeah, I mean, we did build quite a number of automations on top of Swagger. And I think we want to add more automations in terms of on top of Swagger. So it's still stuff that are being developed internally. Yeah.
Thank you. The next one is, how do you verify the quality of the test cases, and does the quality can be reflected? Sorry, a little bit of English. Is the quality reflected in the coverage percentage?
Yeah, so there's two things that we try and measure. Like I said, so success rate of tests is absolutely something that we want to measure, which indirectly says that we're measuring the flakiness of a failing test, and coverage is the other measure for quality. Now, like I said, there are different ways you measure coverage. For unit tests, it is lines of code. For API tests, there's multiple other pieces that you want to look at. For end-to-end tests, you don't want to probably look at whether you're hitting APIs, or you don't want to look at lines of code. You want to look at whether you're covering user scenarios. So we've got frameworks to calculate coverages for each of these and to put in policies for each of these. Again, vast topic about what is the right coverage and what needs to be done. Again, hopefully once I get my little blog post out, can engage in some more discussion.
Cool. The last question from the participants was NPS or engineer experience measured in this journey, and did this have a measurable impact on recruitment or attrition? I think we should talk about what we can.
Yeah, we should have maybe included a slide on this. Yes, it was definitely measured, and that was a big component of how we drove forward our improvements on our system. So we keep track of it. Do you want to add something, Biju, on this?
We just came out of our NPS survey a few weeks ago. The data is something that we use to determine our roadmap. That is everything that we spoke about here is things that we comes out of our NPS survey, hopefully making engineers' lives better as we take every day forward. And again, we don't have all the answers to everything as a platform team. We rely on people to give us those answers, and there are really smart people at Grab who tend to have suggestions and ideas coming through.
Thank you. I would like to address a couple of points. A couple of folks asked if, because they missed a part of the talk, can they watch the recording, or where can they watch the recording? Unfortunately, I don't have that answer, but to all the people who have registered, I will try and share the slides with you to begin with about the recording. We'll get the clearance internally and then share the recording file with you, or upload it on one of our social media platforms, depending on how it goes. But we will keep you posted via email. I think that's about it. Thank you so much, Biju and Sylvain, for taking out the time. And thank you so much, everyone who came along and sat through the end. We still have about 30 plus people who stayed on to until 7 p.m. I hope you guys have a great evening ahead, and look forward to seeing you guys again for one of our next Tech Talks, which hopefully would be from the topics that we filtered out from your questions. Thank you so much once again. And do let us know your feedback. You'll be redirected to a web page right after you end this meeting. Thank you.
I just want to say thank you very much, Isha, for hosting us.
Thanks.
It was really good. Thank you.
Yeah, and thanks to the participant for the great questions as well that we got, and the team for making this happen.
Thank you so much. Thank you.
Thanks, everyone. Speak soon. Do connect with us. See ya.